Okay guys, welcome to problem 6. We have to determine the Wronskian of 1 plus x squared plus x, and 2x squared minus x minus 3, and we have to comment on the solution. So let's begin. So to determine the Wronskian of 1 plus x, have x squared plus x, then 2x squared minus x minus 3. It's going to be formed by this matrix. First of all, we have 1 plus x, then x squared plus x, then 2x squared minus x minus 3. Sorry, there's no comma over here. So then, of course, you know what the next row is going to be. It will be 1 plus x prime, then x squared plus x prime, then 2x squared minus x minus 3 prime. Then the last row will be 1 plus x prime prime. You have x squared plus x prime prime, then 2x squared minus x minus 3 prime prime. So in finding these particular determinants, let's do it together. For this first one to stay as it is, you have 1 plus x, and this will be x squared plus x, and this will be 2x squared minus x minus 3. Then first derivative of the second row is going to give you 1. When you differentiate this term, you're going to get 2x plus 1. And when you differentiate this, you're going to get 4x minus 1. And when you differentiate this one twice, of course, you get 0. So differentiating this one twice is like you're differentiating this, you're going to get a 2. And when you differentiate this one twice, it's like differentiating this, and you're going to get a 4. So this is the Wronskian of 1 plus x squared plus x, and finally 2x squared minus x minus 3. So now the next thing is, what row do I expand this determinant from? Should I expand it from a row or from a column? Some people will be tempted to expand it along this row using your plus, your minus, and your plus convention, but I'll suggest you expand it along this particular column because of this 0 term over here. So plus minus plus, so this 0 term will make your determinant easy to expand. We're not going to expand it according to this column over here, or we're not going to expand it with the, according to the row with the highest number of terms. So we're going to expand it with any place where we can easily get a 0, because it will save you the stress of evaluating some minus. Okay, so in this regards, your w is 1 plus x and x squared plus x. Then we have 2x squared minus x minus 3. W, that's the Wronskian of this value. So expanding along the first column, I'm going to get 1 plus x into the minus of 1 plus x are 2x plus 1 and 4x minus 1, and I have 2 and 4. So when I take the minus of this particular element over here, minus 1, so let me put it like this, minus 1 into, I'll have the minus as this, and this. So we have x squared plus x, we have what, 2, then we have 2x squared minus x minus 3, and we now have what, 4. So by the time I want to take the minus of the last element, which is this particular term, 0, let me just take it to fulfill righteousness, plus 0 into, so if we take the minus of 0, we are going to get, of course, these ones over here, this, and this. So we have x squared plus x, we have 2x squared minus x minus 3, and we now have 2x plus 1, and we have what, 4x minus 1. Okay, so we are going to work with these minus that we've gotten so far. So for this first For this last one over here, just know that because of this 0, everything here is being nullified, so this tends to 0. So we'll just work with this and this particular one over here. Is that okay? So let's write it down. Our Wronskian of 1 plus x squared plus x, then 2x squared minus x minus 3 is equal to, so starting with this one, we have 1 plus x, okay, into, so let's resolve. This times this is going to give me 4 into 2x plus 1 minus this times this is going to give me 2 into 4x minus 1. Is that okay? So we have minus, let me put the minus under, and minus 1 into, sorry about that, minus 1 into this times this is 4 into x squared plus x minus this times this is 2 into 2x squared minus x minus 3. Is that okay? So let's solve. So this evaluates to 1 plus x into, when you open these brackets, you're going to get 8x, okay, plus 4 and minus 8x, and you now have plus 2. Is that okay? Then you have minus, evaluating this one, you have 4x squared, okay, plus 4x, then opening this bracket you get minus 4x squared, then this times this is plus 2x, and this times this is plus 6. Is that okay? So if we evaluate further, we'll get 1 plus x into 8x cancels out 8x, and 4 plus 2 is 6. So we have minus, open bracket, this into this is what? 0. Then 4x plus 2x is actually 6x, then plus 6. So our Wronskian of 1 plus x squared plus x, and 2x squared minus x minus 3 gives, we have 6 plus 6x, okay, and minus 6x minus what? 6. Of course, this cancels this cancels this, and finally we're left with 0. So the W of these three functions, 1 plus x squared plus x, and 2x squared minus x minus 3 is somehow equal to 0. This means that, according to my comments, 1 plus x squared plus x, and 2x squared minus x minus 3 are linearly independent. So since the Wronskian of 3 of them is 0, they are linearly independent. So that's for the 3 of them, and that's for this problem. We're going to solve one more problem on Wronskian, and we're going to look at some applications thereafter. So like, subscribe, hit the notification button, share, and don't forget to stay updated. Check the playlist for areas that you are not clear with, and watch the videos. Okay, so I'll see you in the next video. Take good care till then.